All right, we are finishing chapter 12 today due to some scheduling conflicts coming up in the next couple weeks. This test actually won't be till next Friday. So like you have a week and 2 days, which is good because that gives you lots of study time, but it's bad because it also gives you a lot of time to forget. So make sure that you're staying fresh on it. Maybe take the packet home, kind of revisit it over the weekend. But yeah, we will not do a lesson Monday. We're going to do PSAT prep. Tuesday I won't even see you, and then we'll review again next week. So 2 days of review this week, 2 days of review next week. So lots of review opportunities coming up.
That's great.
What's Tuesday?
The PSAT.
PSAT.
Okay, so we're going to graph these 3 points. We are going to connect the 3 points. That's going to make a triangle. So, -1, 3, you go left 1, up 3. -1, -1, you go left 1, down 1. 4, -1, we're going to go right 4, down 1. And we are going to make those 3 points into a triangle. Now, we learned about right triangles last week, and we used something called the Pythagorean theorem to find the missing values. Now, when you put it on a graph, it's easy to see the distance between the 2 points, right? Going this way? Yeah. All right, so between this point and this point, there are 4 jumps. 1, 2, 3, 4. So that's where A equals 4 came from. Down here, there's 5. 1, 2, 3, 4, 5. But here you can't really count because it's like a diagonal. See that? It doesn't really fit perfectly. See what I mean? You can't really just like jump count it. But what we can do is the Pythagorean theorem. So we're going to do a squared plus b squared equals c squared.
I'm guessing there's a song for that too.
No. So, in this case, A is 4, B is 5. We don't know what C is. So 16 plus 25, that does give me 41. And then what do? Take the square root of 41. Good. Any questions so far? Everybody with me? So now we're going to look at a way you could do this without drawing a triangle. So without drawing a triangle, let me go back. Don't write any of this down. I just want to show you where this all came from. So here, what we were looking for mainly with all this stuff is the distance between this point and this point. That's what we were calling C, right? We didn't really do anything with this point. It just sort of helped us find it. Now, these two had the same X. And if you subtracted the Y's, that gave us that distance of 4, right? These were 4 Y spaces away. Now over here, these two have the same Y, and the 5 is just the distance between the X's. See that? So when we use the distance formula, we're going to find the distance between 2 points by finding the difference between the X's and the difference between the Y's and using sort of a variation of the Pythagorean theorem. That's what the distance formula is. So So let's skip forward back to where it is. All right, so here is that magic distance formula. You are finding the difference between the x's. That's basically one of the legs of your right triangle. You're finding the distance between the y's. That's the other leg of your right triangle. A squared, b squared. And then if we were finding c squared, then we'd take the square root. Well, the distance formula already does the square root part for you. So it's basically taking the Pythagorean theorem and manipulating it slightly that even without drawing the triangle, you can find how much space is between two ordered pairs. Okay? So this is the most important part of today, the distance formula. So you subtract the x's and you square it, subtract the y's, square it, add them together, take the square root, done. So in this case, x1 is the first x value. So when I rewrite this, instead of x1, I'm going to put a 4. Now I'm trying to find how far they are away from each other, the distance between the x's, or the difference between the x's. That'll give me kind of like one of the legs of the triangle. So 4 is my first x. From that, I'm going to subtract -1. That's my second x. Once I do that math, I'm going to square it. Then I'm going to add to that the difference between the y's. So this is y1, it's the first y I was given. This is y2, it's the second y I was given. And then I'm going to square it. Any questions on where this is all coming from? All right, what is 4 minus -1? 5. What is -1 minus 3? -4, good. What's 5 squared? What's -4 squared?
16.
Yeah. Everything after you square it should be positive. Okay, so just be careful here. If you're getting any negatives on this step, you made a sign error. Make sure when you're typing it in, you're using parentheses properly.
41.
All right, and again, we still get the 41. We didn't have to draw a triangle. We didn't have to graph any points. We just used this cool little distance formula. All right, starting with that same old distance formula. What is my x1?
2.
What is x2?
3.
So I'm going to start with 2 minus 3 squared. In the back, my y's, my first y is 0. My second y is 5. I'm going to subtract those two. I'm going to square it. Now, just like a quick little fun fact. What is 2 minus 3? And what's -1 squared?
1.
+1. Okay, what if you accidentally wrote the 3 first and then the 2? Still be 1. And you square it and you still get 1, right? Back here, 0 minus 5 is -5, and -5 squared is 25. What if you flip-flopped it, you did 5 minus 0? And then you square it, you still get 25. So, as long as you put the x's together and the y's together, order doesn't particularly matter here because of what we kind of talked about the other day. You're finding the distance between the x's. Distance is always positive. So when you square it, that sort of takes care of itself. Okay? Questions? So yeah, we just said we're going to get 1 and 25. What's 1 plus 25?
26.
And the square root of 26 is? We don't know. Leave it square root 26.
Weird.
You could do a tree if you wanted. There are no
13 is-
repeaters though.
Can we take it back? 2 and 13.
Yeah, 2 and 13, so there won't be any repeaters. The tree is unsuccessful.
Yeah, you got 5.0990.
Yeah, I don't want decimal answers. All right, any questions? Here is example 3. All right. Same old distance formula. What do I put first?
4.
What do I put second?
1.
In the other parentheses, I put,
4.
and then I put,
1.
very good. So the x's go in the front, the y's go in the back. Subtract them, square them. What do you get in each of those parentheses?
3.
A 3. And what's 3 squared?
9.
And what's 9 plus 9?
18.
18. And can I do a treat?
3.
Yeah, it's going to be 3 square root 2 because it's 9 and 2, and 9 is 3 and 3. The 3s are repeaters. They come outside to play. The 2 stays inside the house. Sad and lonely. Any questions?
Wait, what time do we get out of here? 1:55?
Yeah.
All right, here's example 4. Shh, quiet down. All right, what is my x1?
-1.
What is my x2?
-3.
Now, be careful on that one.
Oh, in parentheses.
3.
Yeah, so in the back we have -2 minus 0. Now, what is a minus negative? So this is like a plus, right? So what's -1 plus 3?
2.
2 is correct, okay? And in the back we get a -2. Any questions on why those are 2 and -2? All right, 2 squared is?
4.
-2 squared is? Still 4? That gives me square root 8.
2 and
2.
2 square root 2.
2 square root 2. Very good. You need to see the tree?
no.
It's 2, 2, and 2.
I can see on your face that you want to see the tree. So 2 and 4, 2 and 2. These 2 come out. This 2 stays inside.
Or in lonely 2.
I thought that there were 2 sets of that. That's why I got confused.
Nope. If there were 2 sets of 2s, it'd be a perfect square, and we would have called it 16. All right. Now we're kind of going in reverse. So I'm telling you what the distance is, and you've got to find the missing value. We're going to set it up the same way, though. We're using the distance formula. Now, previously, we've just sort of dropped off the d equals part, but we can't really do that now because we're going to need that as a clue to find the k. So instead of the d, I'm going to put the actual distance, which is 10, and then these just go into place as they were previously. We're going to do first x minus second x, first y minus second y. It is going to be tough.
That's not what you said.
All right, so we can just kind of start doing the math. 3 minus -3, that's 6.
Can you write it out twice?
Yeah. All right, 6 squared is 36. Now, I'm going to get rid of that big old square root. How do you get rid of a big old square root?
Times a bunch.
No, you don't times it by 2. You square it. So you get 100 equals all that stuff that was left under the radical. All right, now you could do what you said a minute ago. Write it out twice and double distribute. We can actually use some skills that we've learned this chapter, though, to do it a little quicker. So I am going to get rid of the adding of the 36 first by subtracting 36 from both sides. Now, especially with that being equal to a perfect square right here, do you see that?
Yep.
So what can we do to both sides? Square root.
Fine.
Don't forget the plus minus. All right, hold on one second. Let me get the... All right, so from here to here is a step that, had you guys done really well on the quiz, I'd be like, you can handle it. You guys know the grades weren't so hot. So up here, I'm going to show you what you would do in between. You would write it out twice. One of them is positive 8. One of them is negative 8. And you actually go through and you solve it 2 times. Okay, that's where the negative 3 came from. Back here, you get negative 13 equals negative k. And we get 13. All right, that's the first thing I wanted to show you, how we got the 2 solutions. The key is this guy right here. When you take the square root of both sides, you have to write the plus or minus. Now, you might be saying, well, how do you have 2 answers and there's only 1 ordered pair? Is anyone thinking that? Okay, so let me draw you a quick picture to explain why. So it was 3, 5, and negative 3k, right? Okay, so let's just, you don't have to do this, just real quickly, I want you to imagine. So you have a point right here, right? And then we have some point over here along this line, right? And we want the distance to be 10. So let's say we have, what was one of the answers? Negative 3 and positive 13. So they're basically saying there's a point down here and there's a point way up here, and they're both 10 units away. You know what I'm saying? So that's why it's possible to have 2 ordered pairs that are the same distance away from a point. All right? So don't be alarmed if you get 2 answers. This is a very quick, not to scale sketch. Yes?
Tell me if I'm wrong, but isn't the distance... Never mind.
Okay.
It was like...
You can think on it and ask me a little later if you need some processing time. All right. So here is another one. We're going to do the same process. And this is our final example of the day. So it's the same idea as last time. You're given the distance already. And we're trying to find the possible values for k that would make that ordered pair with an x value of 1 square root 17 units away from the point negative 3, 8. So I'm going to set up the distance formula. Boom. Instead of the d, I'm going to put square root 17. Instead of the x's, I'm going to put 1 and negative 3. Instead of the y's, I'm going to put k and 8. All right, we know both of the x values, so we can take care of those right away. That's going to be 4. Square it, you get 16. I'll pause here so you can catch up, because this is where the magic really starts happening. All right, what should I do at this point? Square both sides. And when I square both sides, what am I going to write? Plus or minus with the 17. Okay, the square root and the squared are going to go away. Wait, that's not right. I'm getting ahead of ourselves. We don't have the plus minus yet. Where does the plus minus come in? When we take the square root. Yep, not squaring. Sorry, I'm getting ahead of us. I was going to say that doesn't look right. Yeah, subtract 16. Now what do? And here's where we write the plus minus. Yep, so everybody good? I said something that was wrong. I mean, first time ever. Never happen again. Can't even believe it. All right, so here's where we take the square root. Maybe.
Wait, what?
There it all happened at once. Take the square root of both sides. That's when you do the plus minus. Yeah, the square root of 1 is 1. I know, everyone always forgets that one. Here's where we do the plus minus. Here's where we write it in two separate equations. So we have 1 equals k minus 8 and negative 1 equals k minus 8. So yes, the step where you take the square root, that's where you put the plus minus. All right, so what's our first k?
K9.
9. And then back here, when you add 8, what do you get? 7. So our two k values that are going to work here are 9 and 7.
It's weird because one's K9.
I know. All right, any questions? Again, please excuse my math error.
You should just edit it out of the video.
No, this is going up there. I did it. I'm going to flaunt it. All right, what?
I'm about to teach you. You shouldn't mess up.
Never make mistakes. That's my motto. Never make mistakes. Show no weakness. All right, what did we learn today?
Formula.
The distance formula. All right, here comes your homework. You have the rest of class to work on this. We will go over this tomorrow, and then like I said, we're going to start reviewing. We've got a long stretch of review, so please don't blow this off thinking the test will never come. It will. It's just going to be a little while, okay? This would be a really, really, really good time, especially if you're struggling, if your grade's not so hot. Start going to tutoring. You could get like 8 days of tutoring in between now and the test, okay? So come see me if you want to be one of those people. Got it?